In this video, we're going to learn how to find distance using the Pythagorean theorem. So we're going to take 2 points. We're going to draw a right triangle that connects those 2 points, and we're going to find the hypotenuse of that triangle, and that is going to give us the shortest distance between the 2 points. Our first thing that we're going to do is find the hypotenuse of a right triangle. This is just a regular Pythagorean theorem problem. So we find the hypotenuse, which is the side across from the right angle. That is our C. And then the legs are A, and the legs are A and B. So we can plug this in as 6 squared plus 5 squared equals C squared. 6 squared plus 5 squared simplifies to 61. And our last step is to take the square root of both sides, because remember, squaring a number and taking the square root of a number are inverse operations. So when we take the square root of C squared, we are left with just C. And when we take the square root of 61, we get approximately 7.8. So the length of this hypotenuse is approximately 7.8. So now we're going to use the Pythagorean theorem to find the distance between these 2 points. So these are the points 3, 8 and 8, 2. So we have a right triangle that can be drawn to connect these 2 points. And we're going to determine the side lengths of the 2 legs of the triangle. And then we're going to use those to find the hypotenuse, which is the distance between them. So the side length of the first leg is 1, 2, 3, 4, 5, 6. And the side length of the other leg is 1, 2, 3, 4, 5. So we're going to label these A, B, and C. This is our C, our hypotenuse. When you're doing distance, you're always going to be finding C. And this is A and B. So we have 6 squared plus 5 squared equals C squared. And this is the same exact problem as this one over here. So we know that the distance between these 2 points is going to be 7.8. So now we're going to do some guided practice. Number 1, we're going to find the distance between the 2 pairs of points. So the first thing is we're going to draw our right triangle. It doesn't matter which direction you draw it, so you can draw it like this. You could also draw it like this. It doesn't matter, it's going to give you the same answer either way. So we're going to draw our right triangle to connect those 2 points. Then we're going to count our side lengths. 1, 2, 3, 4. 1, 2, 3, 4, 5. And we are looking for the distance between the 2 points, which is the hypotenuse of our triangle. So we'll plug in our A and B to the Pythagorean theorem. 4 squared plus 5 squared equals C squared. We take the square root of both sides. So we know that C is equal to the square root of 4 squared plus 5 squared. So the square root of 4 squared plus 5 squared is approximately 6.4. So C is 6.4. So that is the distance between these 2 points. Number 2, we draw our triangle. So that's our right angle. That means that this is our hypotenuse. So we're going to count the side lengths. This is 1 and 5. So that's going to be our A and B. When we plug it into the Pythagorean theorem, we have 1 squared plus 5 squared equals c squared. So we know that 26 is equal to c squared. We take the square root of both sides because the inverse operation of squaring a number is taking the square root of a number. So c is approximately 5.1. And number 3, we're going to draw our triangle. Again, it does not matter how you draw the triangle as long as you use it to connect your 2 points. This is our right angle. That makes this the hypotenuse. Now we're going to count our side lengths. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3. We're going to label these A and B. Remember, it does not matter which is A and which is B. So 8 squared plus 3 squared equals c squared. 8 squared plus 3 squared is 73. We take the square root of both sides, and we get that c is equal to approximately 8.5. So what we just found is that the distance between these 2 points is 8.5 units. And it's approximately 8.5 units. On number 4 and 5, we're going to find the distance between the 2 points. We just don't have a graph. So to do that, we're going to find the change in the x-coordinates. And so change just means how many numbers it takes to go from one x-coordinate to the other x-coordinate. So to go from 5 to 9, we are moving 4 units. So we're moving 4 units. And then we're going to look at the change in our y-coordinate. So to go from 6 to 10, we are moving also 4 units. So what we can do is we can draw a triangle to represent this movement. Okay, so the x value goes left to right, and the y value goes up and down. So remember, this was our x values, this was our y values. So we're going to put 4 units left and right and 4 units up and down. And now we're going to find our hypotenuse, which is going to give us the distance between our 2 points. So we'll plug this into the Pythagorean theorem. A, B, we're looking for C. So we have 4 squared plus 4 squared equals c squared. We're going to take the square root of both sides and be left with c. So we get that c is equal to the square root of 4 squared plus 4 squared, which is approximately 5.7. Our next one, we have 4 and 8. So the difference from 4 to 8 is 4 units. And then we have 6 and 1. So the difference from 6 to 1 is 5 units. So we're going to draw a right triangle. So our X, which is our left and right, is going to be 4. And our Y, which is up and down, is going to be 5. We're going to find our hypotenuse, which is the distance between our 2 points. So we basically just made a visual representation of that distance between the 2 points after we determined how many units were between the X values and the Y values. So now we're going to plug it into the Pythagorean theorem. So we have 5 squared plus 4 squared equals c squared. 5 squared plus 4 squared is 41. When we take the square root of both sides, we get the square root of 41, which is approximately 6.4. So C is equal to 6.4.